Lesson 9.8, determine absolute min or max algebraically. And so think back to the very first lesson we did in this unit of an absolute max or min is the highest or lowest that point ever goes. Polynomials normally go on forever, negative infinity to infinity, but they're giving us a closed interval. And so what's going to happen then is really a min or max absolute could be on an endpoint. So it could either be on an endpoint or inside the interval. That's what you have to figure out here. So again, this is not going to be on Delta Math until you answer the question. I just put this on here to show you that it matches and that it works. So what I would first do is figure out your critical points. So we've got a prime of x would be 3x squared plus 18x plus 24, factor out of 3, that'd be 4 and a 2, so that would be at x equals -4 and x equals -2. Okay, so find critical points. We're also going to use the endpoints. Now I want to make a table, an x, y table, listing all of those things from smallest to biggest. So smallest x value would be -6, then -4, then -2, and then 0. And you're plugging them back in to the original. Plug back into original function. Because that's all you're really doing is trying to figure out what is the y value. This just helped us algebraically figure out where that's happening. So we've got -6 square or cube, sorry, plus 9 times -6 squared plus 24 times -6 plus 9. We got -27. So it's saying at -6 we get a y value of -7. That's pretty low. Now what I'm going to do is I'm going to go back up here, steal this, and now I'm just going to change that I'm plugging in -4. And we get -7, so we're increasing, right? Take it again, plug in -2. -11, go back down a little bit. And then plug in 0, I could just do that because that's zeros until 9. One the absolute maximum. So what that's saying is any of these x values could be the absolute max. And I see that that's going to be right here because the highest y is 9. So this graph, see there's a point at -6, -27, that's the absolute min. And then we have a little bit of a relative max here, and then we go back down to relative min and then an absolute max. So, yeah, so we just want the y value, so that would be 9. The number 2, given the function, again, determine the absolute min on the closed interval -3 to 1. So we would want to take the derivative to find the critical points. Factor, once you set it equal to 0, take out a 4x, that would be x squared minus 4. This is a difference of squares, but I'm going to go ahead and just solve it. So I know I'm adding 4, square rooting it, so that's positive and -2. Because 2 squared is 4 minus 4 is 0. -2 squared is 4 minus 4 is 0. Okay, so these are all options along with the endpoints. Because again, a high or low point can be on a closed endpoint. Lowest value would be -3, then -2, then 0, then 1, then 2. And you would just plug them back into the original function to see what they get. And I'm going to cheat since I have the graph, but you know how to do that. So at -3, it looks like it's at like, I don't know, 12, kind of making it up right now. -2 looks like it's at -15. At 0, it's at like 2. At 1, it's at about -5. Now something I forgot to do is 2 doesn't even fall in our domain here. So I actually didn't even need to use that. So that's very important too. When you get your critical values, take out any that don't fall in this domain. And so if I'm looking for my absolute lowest point, that would be right here at the -15. Now, if you get the same question on Delta Math, I'm not saying that's the right number, but you get the gist.